You have a lot of interest. How will you connect them into a great job? This may be fine for watering the lawn, but if you try to use a garden hose on a machine like this, it would be a disaster. When it comes to lifting, drilling, plowing, digging, harvesting, and building in our modern world, garden hoses just won't do. You need stronger, more durable hydraulic hoses. Parker Hannifin Corporation, based in northeastern Ohio, has a division that is dedicated exclusively to the design, fabrication, and testing of some of the most powerful hydraulic hoses on the planet. Becky Ramsay is a chemical engineer at Parker and oversees a team of bright and innovative designers.
My job as a technology team leader is to look for new materials and new technologies that we can use in those hoses to help make them better and more useful for our customers in their challenging environments. One of the products might go, say, on a piece of construction equipment. So if you have a backhoe with a big arm that comes up and over, that's all controlled by hydraulics, and then the hoses are what's going to convey that fluid and convey that power over the length of that arm. So we need to kind of beef it up and make it so it's robust.
Unlike that garden hose attached to your house, these heavy-duty hydraulic hoses can contain up to 6 different layers, from the inner tube that actually carries the fluid, to several layers of fiber or wire reinforcement, to the outside cover, which is exposed to all environmental conditions.
So we might be doing research and development on any one of those different components because they all have to work together to make that hose do what it needs to do in the field.
And these individual components are made of synthetic polymers, basic compounds chemically created in a lab.
Victor Hama is our chief chemist here. So he's back in our mixing room and he's figuring out all the different ingredients that need to go in a rubber compound to meet the design criteria that an engineer needs for a hose.
Victor combines these ingredients together in a couple of giant mixers. The result is a long, flat piece of polymer material with a unique set of properties. From this, Victor will cut square samples that Becky will cut down into even smaller samples to conduct tests. The first sample she creates is called a tensile bar, something the engineers refer to as a dog bone.
So the tensile machine is something that we use to sort of figure out how tough a rubber compound is. And then what this machine does is it calculates how much force it takes to pull that dog bone sample apart. So you can see all these numbers here are changing as we pull. So our strain, that's how far we're pulling the sample. And then you can see the graph is, growing here. So what we're tracking is the axial strain, meaning how far we're pulling the sample. And then on the y-axis there, we have our tensile stress, or how much force it's taking to pull that sample. So what we do then is look at that data and make sure it's all in line. That if we're testing 3 samples, that all 3 of those samples are acting in very similar ways. Because if they're not, there may be a problem, and maybe it's a defect within the sample, or maybe it's an issue with the test. Maybe the sample maybe slipped a little bit out of the grip. So it's important to understand how those numbers are calculated, because the real world is not cut and dry.
After Becky determines that the material is strong enough, she runs several more quality tests. If the material makes the grade, then it's time to design and manufacture the hose. Remember those multiple layers? Well, other engineers at Parker specialize in designing the layers so that they all interact properly and work together. Another test that is carried out is called a burst pressure test. This test is run by a lab technician who puts the test hose into a chamber behind bulletproof glass. The hose is then pressurized with water until, yes, you guessed it, it explodes. The data generated from this test tells Becky how much pressure the hose can hold before it blows up, which in turn provides Parker's customers with some very important safety information.
We're always asking the question, how can the product be better? How can it be stronger? How can it be tougher? How can it last longer?
Growing up, Becky's natural curiosity led to a love of math and science. So because of this, she enrolled at Case Western Reserve University and studied engineering.
You like science, you like math, you like physics, you like all of that. And engineering is one of those ways that you can go down any one of those different paths depending on what your particular interest is. Make sure it's something that really excites you and really make it your own, because that's going to drive you, it's going to drive your curiosity, it's going to give you that information that you need to know what it is you really want to do when you go to college and finally, when you end up with a career.